Well, let's do this here. So again, good afternoon. My name is Greg Valoria from the Nerd Soccer Media Network, and on behalf of the Cal Poly Graduate Education Program, we thank you for attending Systems Integration Engineering Professional Certificate eInfo session. And I'll be moderating the session and also the QA period right afterwards. And so before we start, let's do some housekeeping. For those on the Hangout Live, which I don't see anyone right now, everyone wants to just view it on their screen. If you can mute all your microphones if you're not presenting. If you're lucky to be on the Hangout, you may ask questions during the QA session live, but if you're viewing this on Google Plus Hangouts, which we have about 6 viewers right now, to ask questions during the session, you'll need to press the QA button in your upper right-hand corner there of your viewing screen on the event page there. And then a new window will appear, and then a grid of 9 boxes in your upper right-hand corner will appear. If you click that, a new screen with a QA button will also appear, and then once you hit that, a sidebar window where you could ask questions live would be perfectly fine. And you could do that at any time. So queue up as many questions as you want while people are talking, and I'll make sure I have my Q&A screen up and running. In fact, I'll go ahead and kind of turn that on right now. And so if there's any questions you have immediately, you could go ahead and queue that up. But anyway, let's go through the agenda. With this seminar, we hope to give you a glimpse of the Systems Integration Graduate Certificate Program at Cal Poly San Luis Obispo. And let's go over the agenda real quick, like I said. So today's guest, Kurt Colvin, is a professor from the College of Engineering and Director of Systems Integration Engineering Certificate Program at Cal Poly San Luis Obispo. And he'll briefly discuss the program. And then next after that, we'll have Mike Dirkes, a veteran of the aerospace industry and currently a systems engineer at ENSCO and a current certificate student. And then after that, we have Mike. After Mike, we have John Bishop, another veteran of the aerospace industry, on why companies would invest in an employee's education, which is kind of interesting, and that's how we're targeting people today. So let's get started. Take it away, Professor Kurt Colvin, and I'll share the screen with you there. Okay?
All right, thanks, Greg. So I'll go ahead and let you bring that up.
Yep. You see it all?
Yep, and I think if you just go ahead and shift to the next screen, I'll just go ahead and start it. And what I just want to do is kind of approach a definition of systems integration engineering, and then talk a little bit about the logistics of how the program works. So if we think about systems in terms of this system life cycle here, this is a very abstract, simple model of kind of how engineering life cycles go. What happens at the very beginning is somewhere, someone, some entity, some stakeholder has a need, or it could be a group of people have a need, and they hire or they engage a set of engineers to somehow solve the need they have. And that could be a problem like a system doesn't exist. It could be that we're having a problem with an existing system and we need a fix or a solution. Those kinds of things becomes needs or engineering problems. The engineering team goes to work and they come up with a plan to solve that problem. That would be the design. They go through a lot of work to kind of verify that design would actually work. Once we move past those activities, then we move into a test phase, and that would be to verify that the thing we've designed and built actually solves the need. And once we've kind of gone through those iterations in that phase, we would move into the operations phase. And often that's the longest duration phase of the entire life cycle, is we operate systems for sometimes many years. Finally, at some point, the system becomes obsolete, or new technology comes along, new ways to do things, and so that system would move to a dispose or a closing phase. And in the meantime, it's probably this system life cycle is going on again for the same problem or need. So that's just kind of a very abstract model of the engineering system life cycle. I'd like to start out with a couple of definitions, and this is working up to a definition of systems integration engineering. So the first thing would be a system. And if you think about systems, go ahead, Greg. It could be something like a military defense system. So that would be one aspect of the system. Or we could have, a communications device. So you could think about that, and we could scope the problem we're talking about in terms of that. We have healthcare systems. That would be another type of system we could discuss. An auto manufacturing system would be another level. And so that's kind of, once you already have the design, we have to come up with a system to produce that. So in terms of a very generic or general description of what systems are, I just call it a set of interacting entities that have some kind of a function or purpose. So something you group together and say, these things together achieve this function. In terms of integration, and I lost that screen there. I don't know what happened. Oh, maybe I'll just click on it right here now. Yep. Thank you. In terms of integration, you think about all the pieces of the puzzle that we put together, and somehow we come up with a whole. So integration then is simply just, go ahead, Greg, is just to bring things together into a whole. So a pretty simple definition of that. And then finally, engineering. And I like to describe engineering in terms of using science and technology to solve problems. And so engineers attack problems that are presented to them. They use science, and I'm really talking about the scientific method of having a hypothesis that this design we're coming up with will actually solve the problem. And then the technology, we get the advantage of using all these past technologies that previous people before us have developed. We get to use those techniques and tools to solve problems. So finally then, engineering is just solving problems using science and technology. Okay, so individually, that's what those three words mean to me. And then when I come up with the systems integration engineering definition, and I've kind of pulled this together from several sources, but really it's a process, an engineering process that evolves and verifies an integrated lifecycle balanced set of system solutions that satisfy customer needs on time and within budget. That to me is systems development, and this systems integration engineering is the methods and the process that you basically organize a group of people together to develop a solution within these kind of constraints of time and budget. So that to me is a bit of a definition about what the topic systems integration engineering is about. And if I were going to talk now, I'm going to present a lot of information here, but I'm trying to communicate how this structure of the program is set up. So the certificate consists of 4 classes. They start with SIE 509. That's the orientation session. The systems class, the introduction to systems, is 510. SIE 511 is the design phase of systems. And then finally, integration is the putting together of all those things. So it's 4 classes that are kind of set up in sequence like that. Go ahead, Greg. And the timing of those is the first one, the SIE 509 class, happens right at the end of summer. It's a 2-day, 1-unit class, and it's actually on site here in San Luis Obispo. We come together, we meet each other, we cover some basics, and then we kind of set ourselves up for the rest of the year. So then the SIE 510 class is 10 weeks, and that matches with our fall quarter. We have 10 weeks quarters here at Cal Poly. And it's a 4-unit class. We meet online, 2-hour lecture periods twice a week. We do it on Monday and Wednesday evenings. So then that's the first 10 weeks before Christmas. Then after Christmas we have the winter quarter. That's another 10-week session, a 4-unit class. And then finally in the spring we have the spring quarter and the 10 weeks of SIE 512. So together, that's 13 graduate units that compose what the graduate certificate is awarded at the end of that. Okay, so that's kind of the unit measures. And then in terms of where it happens, well, this SIE 509, it is actually on-site here in San Luis Obispo. We get together, we meet for 8 hours on a Friday, 8 hours on a Saturday. We cover some basics. We do a lot of activities to kind of get to know each other. And that relationship we established there early then allows us to have our online classes in a way that we're able to communicate pretty effectively online. So the 3 classes, there is no on-site classroom. It's all an online collaboration that we have. Okay, Greg, keep going. So the cost of the program is $500 per unit, and the program cost total then for the 13 units is just 13 times 500, so $6,500. The program is run through the Extended Education Office at Cal Poly, and I think that's about all I want to say. Yeah, that's the whole package. So finally, I often will talk about an analogy of systems integration engineering and an orchestra, things like the interacting components and the function or the goal you're going for to develop a system. The integration is having to work everything together, and engineering is our approach, engineers' approach to solving problems using science and technology. So feel free to check out the website. There's some more detail there, and then my contact information. So I'll pass it back to you, Greg. Thank you.
Yeah, thanks, Kurt. That was a great presentation. Yeah, and some more people have joined us now, and so if you want to ask some questions, and you're on the viewer screen, hit the QA button on the top right, and then a grid of 9 boxes. Hit the grid of 9 boxes, and then hit the QA, and then the QA sidebar will show up in your viewer window, and you could ask questions that way, and I'll moderate the questions and ask them at any time because they'll show up on my moderator screen online here. So. Appreciate that, and thanks for joining us again, and thanks again, Kurt. So next up, we're going to go to Mike Dirkes. He's currently a systems engineer at ENSCO and a current certificate student. And he'll talk about how this program will help, has helped and will help his career. So go ahead and take it away, Mike.
All right, thanks, Greg. Yeah, as Greg said, I'm a current student, and so I'm going to talk about a few points about the class today. One would be why did I decide to enter the program? And next would be, hey, what are the benefits? What things have helped me? And then a little bit just about taking an online class, because that was different for me, and I know a lot of students. So first, why did I decide to take the course? Well, first off, I may not look like the typical student. I am older, but I'm always learning, especially in the engineering and sciences field. There's always something new to learn, and everything's changing. So a little bit of my background in why I say things are changing. I've been in the aerospace industry 30 years, and it's taken me very different directions over time, so a lot of different opportunities, learning something new all the time. So that's why I kind of think I am your typical student, because I'm always having to learn. I graduated from Cal Poly with a degree in electronics, but my first job right out of school was as a programmer, and I'd only had one programming class in my whole life. So that was my first learning experience right off the bat, and that was on the space shuttle program. So programming on manned flights a little critical. I then spent many years as a test engineer working on the V-2 bomber program and Titan rocket programs. Again, totally new things for me, a lot to learn in both times. After a few years, I started to become a lead on many projects. So I thought, hey, I really like this management stuff. Let me go look into a master's degree in engineering management. So I started down getting a master's degree. During that time, I got promoted to a program management job. So I'm like, well, I need to learn a little bit more about that too. So I got a certificate in program management while I was getting my master's in engineering management. They went together really well. And I was a program manager for many years. But lately, I got more involved in systems engineering. And of course, I didn't really have any education in that or training in that. So it's kind of been a learn by doing. And when I saw that Cal Poly had the certificate program, I just really jumped at that as an opportunity to really learn systems engineering. What am I supposed to be doing in my job, not just what I, try to get by with. So I think that's been good. And in general, I think, hey, whether you're young in your career or a veteran person like me, there's always something to learn and a reason to get more education. Some of the benefits that I've seen in the class is that, in general, systems engineering is important to all of us. We may not see that we need to worry about a full system or the whole life cycle, like Kurt was talking about, but we are a piece of that no matter what we do, and it's always important to understand those interactions. How our work affects other people and how their work affects us. And the more you know about the whole process, the better you're going to be at your job and understanding those interactions and the overall integration of a product. During our class, we have studied, all the different phases of systems engineering and that product life cycle. So as a student, there was many things of interest to me, and I know for you too as a student, there'll be many topics as we go through the whole product life cycle. No matter where you currently work, there'll be things of interest, and it'll help you as you evolve in your career. And a lot of our coursework that we've done has been about process improvement and how do we make the process work better, faster, leaner, and that type of knowledge can be applied to no matter what you're doing in your work and even in your home life. So there's a lot of benefit from that standpoint. The program for me has been a great match for my work. I was actually been really surprised at how closely our topics have matched with what I've been able to do, and I've been able to immediately apply what I've been learning. I'll give you a few examples. The first quarter, John, who's going to speak next, taught us about SIPOC, which is supplier, input, process, output, customers. Within a few weeks after learning that, I was given the task to do what we call a giver-receiver list of okay, that interface. And so I got to use that knowledge right away. And, the second quarter, we spent a lot of time learning about reliability, maintainability, availability, what people usually just call RMA. And within a month after that, I was working availability numbers on my program and questioning, hey, where did these numbers come from? How were they devised? And we found out that they were actually not very accurate, and I was able to help develop better numbers for our availability. This quarter, we've been learning about the interfaces and testing. Well, right now I'm on a test team for a big project. We're working as a whole working group, coming up with a big test plan. And I'm also working on the interfaces between many of our subsystems. And so writing new requirements and straightening out our requirements. So it's been just amazing how every quarter there's been something I've been able to apply right away. So you can kind of hear that the knowledge that I've learned has really benefited me, and then of course benefited my projects that I work on and my company. One of the aspects of this to me was taking an online class. I hadn't ever taken a real online class with video. So before starting the program, I was a little concerned. Hey, would I learn anything in that environment? And would I like the online aspects? So, as I've already said, I already learned a lot, so that's been great. The online aspect, I think everybody was really surprised in our class how well it has worked. There's many pieces that had to come together correctly for it to work right. We used the orientation to start off that Kurt talked about was great. Everybody came together in person. We got to meet, start building those relationships. Most of us have continued through the whole sequence of classes. So that relationship and that trust when you're doing it online is a real key bond. And so you feel comfortable discussing topics and bringing suggestions forward or examples forward. The other thing is the application, the Zoom application that we use. It's the audio and video application we use. It's been easy to use, and it's been really nice seeing and hearing the people real time during our class. If somebody coughs, you hear it, and you can react, or if somebody starts to interrupt, you can hear it and acknowledge, what do they have to say. It's been great. The other kind of third part of it is the PolyLearn, where all our class assignments get posted. There's additional resources on there and discussion forums. So those three things together have made it really good from an online class. The other aspect is the relatively small class size. I mean, we have had, I think, usually about 12 people or so, somewhere around there. And it makes that interaction really good. And it's the student experience is good from that standpoint because you can hear what other people are doing, what their work activities are. We all come from various industries and various work experiences, but we can bring that to class, we can discuss it in class, we can apply what we're learning directly to work experiences. And Kurt works really hard to make sure that our lectures and discussions, match with what the various people are doing in work. And we've actually had sessions where we talk, hey, what are you doing today? What was today's job? And we talk about what people are doing in class. Kind of the last aspect of the online that's worked really well is we've had direct input to the course content. So as a group of students, we'll talk about, hey, what should we be learning? Kurt has a lot of different topics we can talk about, and in general a guideline, but it's almost like a moderator, helping us guide us through what things are the most important for us as a group to learn. And that's been really beneficial. We've tailored our coursework to exactly what the students need and want. So that's been all great. So I think the bottom line is that I look forward to going to class every couple of days. I mean, I miss it when we don't have class. I've enjoyed the work assignments, and I would recommend the program to anybody in engineering or sciences. They don't have to be a systems engineer or program manager, but they maybe are headed that way, just like I was. I like understanding a lot of the different topics, but it's just really good for any engineer to understand the overall process and how they fit into that process and how all those interactions to work to develop a product.
Yeah,
Now back
wow.
to you, Greg.
Yeah, no, that's great. No, thanks, Mike. Appreciate that. It's really, you have chances to ask questions at the end of Mike and whoever presented to Kurt and upcoming John. If you just press the QA button in your viewing screen there, if you want to ask some questions. And I don't see any questions queued up yet, but keep on thinking about them, and we'll go into a small QA session if I don't get any questions, and we'll do that. But anyway, thanks again, Mike. Anyway, next we have John Bishop, a longtime aerospace global operations vice president for Boeing, and later Sikorsky, and currently consults internationally on starting new operations, and a co-founder of Leadership is a Verb, where he writes thought-provoking blogs on leadership, virtual cultural awareness, and careers. So John will discuss now why companies would invest in an employee's education. So anyway, take it away, John. Appreciate it.
Thanks, Greg. I'll try to be brief, so we do leave a little time for questions, but we'll see how it goes. I've kind of skinnied it down to 3 points, okay? And first of all, so why are businesses interested in this or any program? And then I'll bring it back all the way to the closure with why this program. The first one is anybody who participates in any kind of a program, whether it be a master's, continuing their education, getting certificate programs, it demonstrates to me and to leaders of the company that they have an attitude about self-improvement, about continuous improvement, about keeping their skills current. There's a term that I like to use that I read somewhere. I'd like to be the person who invented this, but I can't. The difference between job security and employability. And it seems really subtle, but job security was a thing that our parents used to talk about. And it was that thing where you stay with a company for 30 years and then you retire with a gold watch and a pension. And it may be somebody like me did the same thing, okay? It may be that you too do the same thing. But there's another way of looking at the same, and that is if you continuously increase your skills, you continue to keep yourself more or make yourself more and more employable. Now, the interesting thing about that, it may be employable where you are, or it may be employable elsewhere. But in either case, it's all about employability and making yourself more invaluable to your current customer, and that's what I call employers, your current customer, or your future customer. And what I like to say is that if you continue to make your skills more and more employable, then obviously your current customer will see that value and reward you appropriately. The second from a company standpoint, and I know this sounds rather kind of matter of fact, is we can make or buy talent. Okay, we can make or buy. So make means that we train them. Buy means that we recruit them. That's the only way, two ways you get talent at a company. Now, when it comes to systems engineers, it's a little more tricky because, or it's the people who understand systems, and that's because it takes a lot of time to learn those skills. Whereas just a mechanical engineer, you can go hire a mechanical engineer, or you can train a mechanical engineer, electrical engineer, aero engineer, whatever you need, industrial engineer. But to find somebody who understands, as Kurt's model, all the way from the need to the disposition of whatever it is you're working with, that's a pretty broad thinker. And usually in industry, whatever industry it may be, those tend to be the people who have been there for a long time. They tend to be your system engineers, they tend to be your chief engineers. And they got those skills not by design, based on time. And what this program is all about is trying to shorten that learning curve so you have the skills to go ask the questions. Like I think Mike gave a great example where he learned something in class, went to work a week later and said, and he asked a question that he probably wouldn't have asked had he not taken the course. It's not like he knew everything about SciPoc or he knew everything about, I think it was not reliability, but availability. It's not like he knew everything about that topic, but he knew enough to ask a question about the topic. And then through the people who are experts, he probably learned something from the conversation. And I think that's really important. And now the other thing I want to bring up in that same vein is, if you look at Kurt's original slide that said what a system is, you notice that they weren't all engineering systems. Healthcare systems. The one that I'm mostly involved in my consulting is I set up production systems. There's a lot of engineering folks and a lot of engineering concepts. But at the end of the day, I'm setting up production systems, everything from hiring workers to building buildings to then providing product. So this curriculum is applicable to certainly to systems engineers, but also to other people that do work within larger systems. And then the last point is, so why this one? And I think one of the keys here, and Mike touched on it a little bit, is that in addition to being an online course, Kurt has taken a lot of time, and I've actually worked with Kurt for maybe up to 10 years now in exploring and developing concepts of how to have teams work effective virtually. And if you're one of the very few people in the world that get to work on a program or a project where everybody is an arm's distance away, that's probably unusual. It's always that they're in other buildings, other states, other countries. And your skills on and how you can work with a virtual team nowadays is more critical than others. And what Kurt and a few of us have done is we've baked into the program how these learning disciplines about how to work effective virtually. So it's not just a virtual class. We're actually teaching the skills of how to work virtually while you're learning the class. And it's kind of force-fed, and you may not even realize it's working, but that's one of the reasons why it's working. So with that, I think I'll turn it back over to you for any questions and maybe an answer.
Oh, no. Thanks, John. That was really good. You know, again, if you guys have any questions out there, we have about 15 viewers. You just press the QA button in the upper right-hand corner of your viewing screen there and follow the other prompts, and you'll get to the QA list. But, you know, I had you know, I don't see any questions right now, but I had a question for Mike. So, well, you know, I think with any kind of program that you want to consider, whether it's, you know, online or offline, you know, how is this work-life balance of trying to get your schoolwork in and having a family life and having a professional life kind of work?
Yeah, that's a great question. I was definitely worried about that. I at least had a little bit of background since I had gone through a master's program, and you know had done that. But I think, you know, this class is even easier. Just, you know, small adjustments are required. You know, and a little creativity in your scheduling will minimize the impact. You know, realizes that we're all full-time students. We have a family life, and he works hard to make sure that class is very flexible as possible, you know, from attending class or doing homework. I think our class time that when we actually have the class, 4 to 6, is like at least great for me. I go into work early those days, and I come home early so I can join the class. Some people just call in right from work, and that works fine.
Right.
And so that all those things. One thing I did when I was, working on my master's, and it might work for people too, is I used to commute to work, and so I joined a van pool during that time frame. So I would study on the way to work and on the way home. So that was an easy adjustment that didn't really impact my family at all. And I would, come home for dinner and then go to school in the evening. So I got to see everybody. So there's things like that that people can do. Our like I said, our homework schedules flexible. We Kurt usually assigns pretty light homework between Monday and Wednesday's class, and then more homework between the Wednesday and the next Monday, so that we have plenty of time and we can adjust. Hey, we got many days to get our homework done before the Monday class. So that works out great, I think, for everybody. Everybody's really appreciated that. And Kurt's willing. I mean, there's been times when we've said, hey, we have a little too much homework right now, and so he's adjusted the homework schedule to match to what the students really want and thinks appropriate. So that with that flexibility, it allows us to easily, work our class time and homework around our home life schedule and our work schedules.
It's interesting. Actually, Kurt, I think I have one for you. I have a question from Crazy Racer 933. They want to know how many days a week are the lectures, and second question is about approximately how many hours a week are spent outside of the lectures in your estimation, and thirdly, they want to ask what kind of experience credentials do teachers have in systems engineering? So anyway, we can go over each question if you want to take the time. So.
Sure. The first question is about when do we meet online, and so the schedule is set. We always meet Monday and Wednesday afternoons. We start at 4 o'clock. Actually, we start at 4:10 Cal Poly time, on Pacific time, and it's a 2-hour lecture then. So right on 6 o'clock, we're shutting down and calling it a day. So it's Monday, Wednesday, 4 to 6 p.m., and that's set every week. There have been times that students have just said, hey, I'm out of town, or I have a meeting I have to go to, so they miss the actual online meeting, but I always provide a recording, a YouTube recording of the session so that they can go back and watch either the whole thing or the critical parts. So if you miss a lecture, it's recorded and you can catch up and watch that. In terms of the number of hours per week, I try to go kind of between 1 and 2 hours between Monday and Wednesday of homework. So thinking 2 hours max between Monday and Wednesday, and then somewhere between 2 to 4 hours kind of from Wednesday to the next Monday. So that's what I'm shooting for, and not all of it is, sometimes it's a discussion forum where I'll post a question and we'll post and interact online that way. So that's kind of the first two questions, and then Greg, remind me of the third part of that question.
The last one was what kind of experience credentials do the teachers have in systems engineering?
The teachers.
Yes.
Yeah, right. So I'm the primary instructor, and I'm a professor at Cal Poly, but then I often have helpers, and so I'll call them guest lecturers. So industry people sometimes come. I also have this quarter, I have a visiting computer science professor who's talking to us about software and the software life cycle. So I try to select people that kind of have an expertise in some of these areas, and sometimes those are professors, and other times they're just industry people with an expertise in some topic.
I got it. Okay. We have another question coming in, so it's good. Thank you guys for asking the questions. Again, you just press the QA button on your upper right, and just follow the directions to get to the QA screen to ask questions directly of us here. So this is from Trevor Foster. What does the day-to-day coursework look like? I think you covered a little bit of that, but you might want to talk about it a little bit more. And are there any direct ties or interactions working with the industry within the courses?
Yeah, that's a good question. So in terms of the way the assignments go, so we read a lot. We've read whole books together. We have had just electronic PDF files that they'll often read. I often pull from INCOSE, is the International Committee on Systems Engineering. That's the professional committee from systems engineering. I'll pull information and papers from them. We read some standards sometimes. Sometimes I'll use videos, so there'll be some video content, something I've recorded or that I'll pull from somewhere. Sometimes we listen to podcasts that are very relevant. So I try to make the content varied from many different sources. but always there's some online content that you do asynchronously on your own, and then we come together synchronously and we discuss it during the class times. So there was another question there, Greg. What was it?
Any direct ties or interactions working within industry, within courses. I think Mike kind of talked a little bit about that, and definitely John talked about that, but maybe from your perspective, you could talk about that.
Yeah, that's the beauty. The interaction with industry, or you know, the industry interaction comes from you at your job. That's why all people that are in this program, they actually have full-time engineering jobs. So the idea is that we learn kind of the theory here, but you get to practice it at your job. So there's no other, I don't have sponsored programs from outside industry. It's you and your job is where the practice is going on.
Wow, well, these guys are good. They're asking a lot of questions now. It looks like you guys are really doing your job. So the next question is from Mark Cash. How critical is the experience requirement? He graduated last June. It's over a year now. So technically, he's very short of the 2 years. But however, counting, he wants to count maybe a 6-month co-op he's done and a 3-month internship. So he's very close to that 2-year requirement. So you might want to. Yeah, anyone want to discuss that? Maybe Kurt, or probably you, Kurt.
Well, yeah. So I'll take it really quick. So the requirements for the program are basically two things: that you have an undergrad engineering or technical degree, and that you've had 2 years of work experience. Now, I have discretion to evaluate the work experience and add up your co-ops and internships. So I think we could accumulate 2 years, probably looking back through some history. So I'm very open to looking at that. But in general, two years and a technical undergrad degree.
Okay, it's a question from Brian Smith. Wow, this is good. Would you consider the curriculum classes more based on homework and testing or project-based learning? That's interesting.
That is interesting. So what I would say again is that I try to present the theory and the methods, and then the project is you go to your work and you implement it there. And of course, because people come from many different industries, sometimes requirements discovery doesn't really translate into what they do at their job, but it may be later on when we come to the concept of go to the Gemba to observe the actual work, that's something you could actually engage in and do. So I would say there's kind of hits and misses on all those, but absolutely implementation and practice at your workplace is a big driver in this course.
Okay. So let's go to Brian Smith. He hasn't had a chance. This is kind of a new question. Would you consider the curriculum classes more based on homework and testing or project-based learning? Okay, so it's kind of similar to what you answered. So.
Yeah, let me just quickly say that the homework and testing really comes from the interaction discussions we have. I don't have a whole lot of answer multiple choice questions and get a score. I don't ever do anything in terms of a midterm where you submit the midterm for grading. It's much more of a formative assessment, which is basically helping you to form your understanding and practice rather than a summative assessment, which would be like a final exam or something like that. It's more of the former than the latter.
And Mark had a follow-up question also. Would someone in this position probably get the most out of this class after, at this point in their career, which he had already discussed, it's early on in his career, right?
Maybe John and Mike would.
John would probably be good. Yeah. So the question, John, is that when a person takes this course, would he get something out of it early in his career, middle of his career, end of his career? Well, what do you feel about that?
Yes.
Yes to all of them.
Let me just let me tell you how I would see it if I saw this on somebody's resume. Maybe that would be a way of looking at it. Because you remember all the employers aren't going to be like me who actually know what the curriculum is and know Kurt and know Cal Poly. So it's going to be more generic. I think when I look at a resume, I look at somebody's undergrad, and we all go to school wherever it is we can go to school for an undergrad. We go to the best school we can, but it's all about trying to get through school. And state schools are great, and Stanford's great. And but you just got to get through your undergrad. Then you go on out in the workplace. There's the key. Now, out in the workplace, that's what I'm going to be looking for, is what did they take, how did they get their job, and then comes curriculums like this. Some people are going to go right into a master's program. Some people are going to develop their skills. One of the things that Kurt and I worked with that I thought was really important in my coaching was that any curriculum that you take here would be applicable also to a master's degree at Cal Poly. And so, Kurt did his homework there and made sure that these credits would be transferable to some or all of the degrees. But what I look at is self-improvement. Does the person over a period of time continue to show that they go back to school or they do things to continue to improve their skills? And when I look at that, like I said, we go to whatever undergrads we can go to. But then I look at when you go and you make on your professional on your own as a professional, when you make a decision to go gain more education, are you taking the easy path or the hard path? Are you going to the place who has a reputation for teaching such a topic? And that's the beauty of virtual. So if you're in New York and Cal Poly is pretty well known for systems engineering, which they are, then you should go to Cal Poly. If you're going for supply chain management certificate program, then there's schools that are best at that. And so what I look at on the resume is, did you go to the right places, and did it demonstrate that over the period of time that you have demonstrated that you continue to self-improve?
Yeah, that's good.
I hope that answered it.
Yeah. No, that's good. We have a couple more questions, believe it or not, guys. So I think we'll hang in there with these guys because it looks like they're very engaged with us. So this is from Perry Johnson. And are group projects supposed to be achieved mainly through teleconference or emails, or this is a little bit more details on how the assignments are delivered? And I think Mike talked a little bit about that, but maybe I guess Kurt, you're probably the best one for this.
Yeah, I would say we really haven't exercised doing group projects collaboratively online. We do have a couple of students currently. There's 2 at one company and 2 together at the other. And they are kind of informally working on things together. But I have yet to assign a project and say, I want you to find a time outside of class that you 2 can meet online and do a project. So that's not really the focus of the assignments I've created is I'm not expecting you to coordinate schedules with somebody else outside of class.
Got it. Okay. Thank you.
Yeah,
go ahead.
I can add a little bit to that too, because we where it becomes collaborative is mainly in our forum discussions. So we don't have to be together all at the same time, but we can interact over the forums. Somebody will have a response to something, and we can come back and add a little bit and go back and forth. So those forum discussions kind of work pretty well that way without us having to try to coordinate schedules, because as we talked in our class, it's almost impossible to try to have group projects and people trying to coordinate schedules. But the online forums allow us to do it at our own time frame and own pace.
Yeah, no, that's good. And maybe Mike, you want to? Manuel Carrasco has another question here, and you might be a good one to answer this. So, do you feel there are any technical skills or analysis tools recommended for you guys to review before you probably entered this course? Both Kurt or Mike, you could probably talk about that.
From my standpoint as a student, I don't think so. I mean, of course, I have a lot of experience, and knew a lot of the topics just from my years, but I didn't see anything specific that I needed. I mean, we did, for me, I hadn't done any high-level math for a lot of years, so when we were going through some of the reliability, maintainability, there was some math involved that I had to definitely think about and get my brain working again on, but nothing difficult from a normal, something that a college student wouldn't know. It's just I had forgotten a lot. And other than that, no, I think most of it's pretty, I would call it basic, knowledge, and nothing technical that you would have to say, oh, I need to go study up on my calculus or something like that. No, that's not required.
Got it. Anything to add, Kurt?
Nope, I think that pretty much covers it. It's very much about the overall process. We dive into a little bit of detail once in a while, but never would we go really deep on something like finite element analysis or any detail like that, right? So that's stuff that experts do. We're systems engineer at a higher level.
Yeah, and it sounds like the way you structured this whole program, Kurt, was kind of more graduate school like. I went to grad school and we didn't really have tests, we didn't really have midterms. It was just you read a lot, you learn a lot, and you apply it. That's the best way I could probably describe the graduate school atmosphere versus the undergraduate school atmosphere, right?
And if I would speak up a little bit, it's not me deciding to teach you, it's you deciding to learn something. That's really the approach we take, is I provide the structure and the content, and it's really up to the students to engage and learn it and use it.
Hey, John. Oh, sorry. Go ahead.
I just want to add a little bit to that because some of the subjects, we'll just touch on them a little bit, but if one of the students wants to learn more, Kurt's been really great at providing additional resources, like here, go read this book, or here's some stuff I found on the internet for you to go review. So there's a lot of additional resources if you're interested in something to go work on yourself.
Yeah, that's good. John, you were talking about careers, and I think that's something that this program helps you prepare your career or add or enhance your career. And one thing you touched on was the employability versus long-term. Just you stay in there and you get your grade and you move up because it's seniority effect. But I think the world's changing. On other areas, maybe not as much in the aerospace area, but maybe it is affecting that. But I see where mainly that model is really not as apparent anymore. I mean, there's people moving around from company to company. There's also companies starting and then ending really quickly because they're startups. But when you look at a resume, let's dig into that a little bit more. When you look at a resume, and you were kind of talking about this a little bit, I want to dig into it. I agree. You assume that the person is educated and has experience, right? And then you go to the next level. So maybe you want to go through that a little bit more in detail, how a hiring manager would look at a resume.
Well, first of all, for all the work that we all put into our bachelor's degree, the bad news is for every year after your bachelor's degree, your work experience takes more credibility on your resume. And as soon as you get to some number of years after your bachelor's degree, it's going to be looking at what did you do at work. What did you do to apply that and accomplish something. So when I look at a resume, what I'm looking for is ever-increasing levels of responsibility. And then at certain points in time, and this is where it's key for the couple of questions you had earlier, Greg, where they asked about, is it before master's or after the master's? Yeah. What I look for is what's applicable for the person in their career. And I'll give you an example. Someone coming right out of their bachelor's degree, jumping into the workforce, and then taking an executive MBA. I don't see the line.
Yeah.
Yeah. And that's not to say I don't like executive MBAs. They're great for the right people. But there's the right answer for each one.
Yeah.
And I'll give you a simple example for me. I was industrial engineering, and then after a certain period of time, I did go get an MBA. But then, as you move around in your career, at one point in time, I was put in charge of supply chain management. And I didn't have any of the vocabulary to do the job. I probably had some leadership skills, but I didn't know the details. So where I would ask the buyer, that dirty, rotten scoundrel supplier, can't we do something? Those probably weren't the right words. There's words like, does our contract have liquidated damages? Whereas I didn't even know those terms existed. So what I did at that time, I went down to UCI and I got a certificate very similar to this. I went down to UCI, who's known for their contract management certificate, and I got a certificate in contract management from them. And then it demonstrated to my work for me and to my management that I actually did take an interest in the topic that they've now put me in charge of, or I'm working in. And that it showed that I would actually continue to improve my skills, you see, as applicable.
Yeah, absolutely.
Now, the only other thing I would say in addition to that is, so there is the as applicable, so you got the assignment and you got to go get the domain knowledge. But there's also what I like to say is your aspirational goals. So if you're an engineer and you really want to be a program manager, or you're an engineer and you really want to be a systems engineer, and you go up to somebody and say, I really want to be your boss, and say, I really want to be a systems engineer, and if he or she were on their game, they would say, so what are you doing to get ready? And you go, oh, I just told you, that's all I did. Right?
Yeah.
Versus, I did, and I've already gone down and taken these courses. I feel like I'm getting ready. All I need now is some work experience. You got to give me a chance. And see how it tells a better story about what your aspirations are than just saying, I have an aspiration. It demonstrates that you actually want to do that.
No, we put that on our bosses a lot, I think, John. To make the decision for us instead of trying to seize the moment, right? So.
Yeah, I believe that's true sometimes.
Yeah. Okay. One last question. I think, Kurt, and we'll end this here because we're a little bit out of time. But it was going back to Mike's mention of SIPOC training and question one. And does the SIE certificate tie in Lean and Six Sigma training as well? It sounds similar to some PMP type training added in. So maybe we'll end on that question and we'll just call it a day at that point.
Sure. So in terms of the terms that were thrown out there, so the word lean, absolutely. So my background and my education is all about lean engineering. So that's a definite core aspect of it. In terms of the Six Sigma, so that's a very specific method to get a certification in. No, we talk a little bit about kind of what constitutes a Six Sigma certification, but we don't go down that path at all. And then PMP is a project management professional from the Project Management Institute, PMI. And we definitely talk about project management and the aspects of it. We spend a bit of time in that, but I'm not preparing students to take that certification test or anything like that. All that kind of stuff happens elsewhere.
Okay, great. Well, I'm going to thank everyone who also participated in QA. I was really blown away with a lot of the great questions out there. And anyway, thanks to Mike for being on here with us, current student, and John, who's took the perspective of like a hiring manager and senior VP, and then of course Kurt for talking about the program. Anyway, we'll have this video up in a few days. So you guys could review it. There's a lot of good questions, a lot of good breadth of knowledge that each of these speakers have shared with us. So again, thank you for joining us here for the Systems Integration Engineering Online Certificate eInfo program. So this is Greg Gloria for Cal Poly Graduate Education, and I appreciate you for attending. Thanks, and have a great day.
Yeah, thanks, Greg.